Hi, for those of you that don't know me, I'm Ms. Schuler, and this is part one of reviewing the material learned before we left school for checkpoint number 4. So we're going to review the material that we have talked about, either with me or with another teacher, that we have talked about in the last couple weeks before we finished on the 13th. So here we go. The degree of a polynomial in standard form is the highest exponent of all terms of the polynomial. Remember that a term is like the pieces of a function added or subtracted together. So the degree is the highest exponent that any of the terms have. A polynomial is in standard form if the terms are written from the highest exponent to the lowest exponent. So for example, we have this polynomial here, x cubed minus 5x to the 4th plus 7x plus 3 minus 2x to the 9th. That is not written in standard form because we do not have the exponents of the terms in order from the highest exponent to the lowest exponent. But if you look below the next line, that is that exact same polynomial, but it is written in standard form, highest exponent to lowest exponent. So it's negative 2x to the 9th minus 5x to the 4th plus x cubed plus 7x plus 3. Notice how I kept the signs. So we subtracted 2x to the 9th when that became the first term in standard form. The negative stayed with it. Okay? And then also the degree of the polynomial is 9 because 9 is the highest exponent. Okay? And you can tell that in standard form or not in standard form that the degree is 9. How we can tell something is an even degree or an odd degree polynomial. So the first thing you need to do to tell if a polynomial has an even degree or an odd degree is find the degree like we just did on our last page. If the degree is an even number, then the function is an even degree polynomial. If it's an odd number, the function is an odd degree polynomial. Examples of even numbers are 0, 2, 4, 6, 8, etc. Examples of odd numbers are 1, 3, 5, 7, 9, etc. So we've got a couple examples here. The first example, we have a function 3x squared plus 2x minus 7. The degree of that polynomial is 2 because the highest exponent is 2. So since 2 is an even number, then we know that the function f of x is an even degree polynomial. The second example, we've got g of x equals negative 7x cubed plus 4x. The degree of that polynomial is 3 because the highest exponent is 3. 3 is an odd number, so the function g of x is an odd degree polynomial. Now let's talk about end behavior. The end behavior of a function describes what is happening all the way to the ends of the function, all the way to the left and all the way to the right. The left end behavior is written as x approaches negative infinity, f of x approaches, and describes the graphical behavior all the way to the left of the graph. Typically, our answers when we're talking about end behavior, and it will be for this section, the answers that go in that blank would either be infinity or negative infinity. Infinity if it were going up, negative infinity if it were going down, as you look at the graph all the way to the left. The right end behavior is written as x approaches positive infinity, f of x approaches blank, and describes the graphical behavior all the way to the right of the graph at positive infinity. Okay, same thing. Typically the answers will be infinity if the graph is going up, negative infinity if the graph is going down. There are 4 different scenarios for end behavior that can be distinguished by knowing whether the polynomial is an even degree or an odd degree polynomial, and knowing whether the function has a positive or negative leading coefficient. And we'll talk about the 4 scenarios in a minute, but let's first talk about what a leading coefficient is. A leading coefficient is the number in front of the polynomial term with the highest degree or highest exponent. The important thing about the leading coefficient is to know whether it's positive or negative, and so it would keep its sign, whether it be positive or negative. We have 2 examples here. So the first one, given the polynomial f of x equals 9x to the 4th plus 3x squared, the degree is 4 because the highest exponent is 4. The number in front of the x to the 4th term is 9, so the leading coefficient is 9, and because 9 is a positive number, that's the key here, we're looking for whether it's positive or negative. Because 9 is a positive number, the leading coefficient for this polynomial is positive. For the second example, given the polynomial g of x equals negative 5x squared plus 4, the degree is 2 because the highest exponent is 2. The number in front of the x squared term is negative 5, so the leading coefficient is negative 5, and because negative 5 is a negative number, the leading coefficient for this polynomial is negative. So let's finish with the 4 end behavior scenarios, finish part 1. The first end behavior scenario is if you have an even degree polynomial and a positive leading coefficient. There is an example of that graph to the right, but that is not the only way that graph can look. The key things for this graph are what's happening at the ends, okay? Notice at the ends that we are going up in both, okay? And so that is going to signify our end behavior here, because we basically have both arrows here going up. We know that the end behavior, this one here, is the left end behavior, and it says as x approaches negative infinity as we go all the way to the left, f of x approaches a positive infinity. That's because for an even degree polynomial with a positive leading coefficient, as we go to the left, we are going up. So f of x is approaching positive infinity. For the right end behavior, this is the right end behavior. As x approaches infinity, as we go all the way to the right here, f of x is also going up. So this is also going in the positive direction, which is why f of x approaches positive infinity. So if you have an even degree polynomial and a positive leading coefficient, you have both ends going up, so the left end behavior and the right end behavior both approach positive infinity. So that's the first scenario. The second scenario is an even degree polynomial with a negative leading coefficient. Again, the graph to the right is not the only way that these graphs can look, but the key here is to look at the ends, okay? So for the end behavior, we have this is the left end behavior. As x approaches negative infinity, f of x approaches negative infinity, because as we go all the way to the left, we're going down to negative infinity. This one is the right end behavior. As x approaches positive infinity, f of x approaches negative infinity, because as we're going to the right, we are going down. So we are going down to negative infinity. Okay? So again, if you have an even degree polynomial, negative leading coefficient, both ends go down. So the end behavior of both left and right end behavior both go towards negative infinity. For an odd degree polynomial with a positive leading coefficient, again, this is an example. This is not the only way it can look, but the ends are what we're looking at here. So for the left end behavior, as x approaches negative infinity, notice as we go to the left, we're going down. So as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, as we're going right, okay, f of x approaches positive infinity. As we're going right, we're going up. As we're going left, we're going down. As we're going right, we're going up. So that leads to this end behavior. So odd degree polynomial, positive leading coefficient. We've got as x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x approaches positive infinity. As we go left, we go down. As we go right, we go up. And then our fourth and our final scenario that you can have with end behavior is an odd degree polynomial with a negative leading coefficient. So you've got your end behavior here. Again, this is not necessarily what it's always going to look like, but the ends are what we're looking at here. As x approaches in negative infinity, as we go all the way to the left, notice that it's going up. So f of x approaches positive infinity. That's the left end behavior. For the right end behavior, as x approaches positive infinity, as we go to the right, f of x approaches negative infinity. Why? It's pointing down, it's going down. So that is where we get those. As x approaches negative infinity, as we go to the left, f of x approaches positive infinity, it's going up. As x approaches positive infinity, as we go to the right, f of x approaches negative infinity, it's going down. And that is for an odd degree polynomial, negative leading coefficient. So that is the end of part 1. I'll do the rest of the review in part 2.